Hello and good morning to everyone. In this video, we're going to build a mathematical model, a linear programming model for the following example. And it says, marine engine company specializes in manufacturing boat engines. The demands for engines for the following 9 weeks is 0, 0, 28, 10, 7, 15, 10, 18, 25. Marine has capacity to produce at most 15 engines each week at a cost of 1.5 each. To complete the production, Marine has the option to expand capacity by working extra hours. A maximum of 8 engines per week can be produced in overtime at a cost of 4.5 each. Marine can produce an extra number of engines and store them at a cost of 0.1 per engine per week. A maximum of 7 engines can be stored at the end of each week. The company has to stop production during any 2 weeks to perform preventive maintenance to machines. To production machines, I believe. During these weeks, no engine can produce either on regular or overtime. Write a linear programming model that helps minimize the production and storage cost, considering the following constraints. So constraint A is regular production on week 9 cannot exceed 10 engines. So originally we have 15 as a limit, now we have 10. Overtime production on the same week cannot exceed 10 engines. So previously, normally it's 8 engines. The limit is 8. Now we expand the limit to 10 in overtime. Week 1 and week 2 cannot be both used for maintenance. So we're going to use 2 weeks for maintenance, and we cannot perform said maintenance during 1 and 2. So either 1 or 2 or none of those 2. If week 3 is scheduled for maintenance, then week 7 should also be scheduled. Okay. So the first thing we need to do is to define the variables. Let's write number 1 variables. And so what we need to do is to decide if we are going to meet the demand by producing either on regular time or overtime. So let's write Xij is the number of engines produced in time I during week J. And so we have that I could be regular production or overtime. That's right, E for extra hours. And J is week 1 through 9. Okay. Now we have the option to store engines for later use. So we're going to write another variable. Yj is going to be the number of engines stored at the end of week J. And J again is going to be 1 through 9. And we need another variable to determine when are we going to perform the preventive maintenance. So let's write another variable. It's going to be Wj. Now this variable is going to be a binary. It's going to be 1 if maintenance is scheduled for week J, and 0 otherwise. And I think those are all the variables we need. We may, if we need another variable, we'll just add it later. So let's write the objective function. So we don't have any benefit, we don't have any sale price, we only have costs. That means in this case, for this problem, we are going to have an objective of minimizing the total cost. And total cost is going to be given by the regular production, overtime production, and storage. I believe those are all the costs. There is no cost for preventive maintenance, although that wouldn't matter because we have to perform two in any 2 weeks. If it has the same cost, then it's just adding a constant. So for the objective function, we're only going to consider those three costs. This is minimize, minimize, and here we're going to have 1.5 for regular production. So we are going to have all the engines produced during from j equals 1 to 9 x r j. That is regular production. Now we are going to add 4.5 for all the engines produced in overtime, and 0.1 for all the engines that are stored at the end of the week. And that's the objective function. Now let's go to the constraints. Constraint number 3, constraints. Okay, so for the constraints, we're going to start with the production control, the demand constraint. We have to meet the demand for each one of these weeks. So for the first week, we have a number 0. On the first week, we're going to produce either regularly, week 1, or overtime. And what is going to happen with this production is either we're going to meet the demand or we're going to store those engines for later use, for another week. Now, let's continue. Okay, you have to see the demand. So the demand for next week is 0. So that means on week number 2, we can produce regularly on week 2 or overtime in week 2. And if we store some of the engines, we're going to use them. So we're going to use store engines on the previous week, week number 1. This is going to be used to meet the demand or to store them. Now on week number 3, let's just continue with the same pattern. So here we have X regular production on week 3, overtime production on week 3 plus what was stored on the previous week. This is going to be used to complete those. Sorry about that. Okay, I need to see the demand. Let me write it here. So it's 0, 0, 28, 10, 7, 15, 10, 18, and 25. Okay, so this is going to be used to complete the demand 28 or to store it for later use for week number at the end of week 3. Now in week 4, you can produce regularly overtime. You can use what was stored on last week, week number 3. Here we're going to complete the demand 10, or we're going to store it for later use. The same with week 5, 5, overtime week 5, or we use what was stored last week, and the demand is 7 plus y5. Now on week 6 we can produce regularly, that means regular production week 6, overtime production week 6, or we can use what was left on the last week, that is Y5, and this is going to be used to meet the demand, which is 15, or to store it for later use. On week 7, can produce regularly, over time, or use the stored engines from last week to meet the demand 10, or store them for a later week. 8, overtime 8, plus the stored engines are used to meet the demand 18, plus Y8. And finally, in week 9, we can produce regularly on week 9, overtime week 9, or use storages from week 8 to meet the demand 25, or store them for I don't know, for next period, week 9. So these are the demand constraints. We have some other constraints here. And we have to make sure, I'm going to erase this. And we have to make sure that we do not exceed the capacity. So the capacity for regular production is 15 per week, except for the last week, which is 10 engines. So let's see. So let's take production, regular production at week J has to be less than or equal to 15, but we're going to have 15 only if we are not performing maintenance. If we are performing maintenance that week, then the limit is 0. We cannot have a production if we are performing maintenance. We're going to multiply this times 1 minus Wj, which is, for example, if this was week 1, production, regular production in week 1 could be 15, but if we are performing maintenance in week 1, we have 1 here, and 1 minus 1 is 0, times 15 is 0, so we cannot have production, regular production in week 1. This is going to be for J from 1 to 8. And we're going to complete this with 9, so we have regular production week 9, but we need to change this to 10, week 9. Now overtime production is EJ less than or equal to the maximum, which is 8, 1 minus Wj. And again, if we're performing maintenance, we cannot produce either regular or overtime during that week. And we're missing for week number 9, which instead of 8 is 10. There we go. So overtime, and we also have a limit of 7 engines that can be stored at the end of each week. So let's have Y J has to be less than or equal to 7, and this is for J 1 to 9. Okay. So 10 engines. What else do we need? Okay, so we have to stop production during any 2 weeks. So we need to have 2 values for W equal to 1, the rest are going to be 0. So the sum of J equals 1 to 9 of Wj has to be equal to 10. That means 2 weeks we're going to have maintenance, and the rest of the weeks we're going to have production. When we have maintenance, that means one of these is going to be 1, then production becomes 0. Okay, and what else? So we have some other constraints. We have some special constraints. It's constraint B is week 1 and 2 cannot be both used for maintenance. And that means week 1 and 2 have to be less, because these two are binary variables. it has to be less than or equal to 1. So either this is 1, if this is 1 is a 1, then this has to be 0. If this is a 1, then this one has to be 0 in order to be less than or equal to 1. Or both of them can be 0 as well. That's constraint B. And constraint C says if week 3 is scheduled for maintenance, week 7. So week 3, if this is maintenance, then we need week 7 also be maintenance. So this can be, if this is a 1, we're forcing W7 to be 1 as well. Now W7 can be 1 and this one 0, and that's okay, because there's no constraint over, there's no constraint on W7. So the constraints are only on W3. And I believe those are all the constraints. Hopefully I'm not missing any constraints. Let's write no negativity constraints. So we have xij greater than or equal to 0, and those are integers. Yj is also greater than or equal to 0 and it's an integer. And wj is binary. So this belongs in 0, 1. And I am missing this for all ij and this for j. And this is the mathematical model for this problem. Objective function and the constraints for this problem. So if there are any questions, please leave your comments or questions on the comment section. And thank you for listening.